All right, so once we have set up a hypothesis test, how is it that we carry out this procedure? A lot of people tend to make a comparison between hypothesis testing and a criminal trial because our criminal system is a much more commonly known system in terms of the general ways in which it works. And so I'm going to go ahead and draw that same parallel. Okay, so in hypothesis testing, we assume that the null hypothesis is true. Okay, well, how does that compare to a criminal trial? Well, in a criminal trial, we make the assumption that the defendant is not guilty or innocent, if you will. Okay, innocent until proven guilty. So we're going to assume that what has been said up to this point, what has been assumed, is true. Okay, then what we do is, statistically speaking, we gather data. Okay, obviously, in a criminal trial, they would gather evidence. Same thing, statistically speaking. Okay, they gather evidence, traces of blood or whatever. Well, we do the same thing in hypothesis testing. We gather data, lots and lots and lots of data. Okay, then from there, making the assumption that the null hypothesis is true. Okay, so again, we're proceeding under that assumption. We calculate the probability of getting the sample data we obtained. Okay, so we have this data, it's real, okay, we got it, but then we think, knowing or assuming that this is true, what's the probability that this result we got would have actually happened? Because it did happen, okay? So what's the likelihood of that actually occurring under these parameters? In terms of a criminal trial, well, this is when the trial is actually taking place. Okay, the trial takes place. Let me go back to the statistical version. Give me a medical example that might help clear that up a little bit. So let's say that there's a chemo treatment, okay, that has worked for 40% of patients with a certain type of cancer, all right? So we're going to make a new type of chemo drug, and the assumption is that 40% of the people are going to be cured. That's what's always happened. But then we're going to say, like, we got 45% of our patients were cured with this new drug. What we want to do is look at the probability that if it's really 40%, what's the probability 45% of people would be cured? If that is a big jump, statistically speaking, okay, it would be very rare, then that drug is something new and better. If you're like, really not that big of a deal, because even with the old drug, probability is still pretty high that it could have gotten up to 45%, then maybe you don't tout that new drug as the hot new thing, okay, or the game changer. All right. So going back to our chart here, the last step. So if that probability, that one that we calculated, okay, if that probability, which happens to be called, by the way, a p-value, okay, that's a term that we'll start using, is highly unusual. Okay, and remember, unusual we usually say as a probability of less than 5%. Okay, so if this probability is unusual, then the null hypothesis, H sub 0, is highly unlikely to be valid. Okay, in other words, we need to change our mind. All right, if that probability, if that cancer treatment cures 60% of patients, and that would be really, really rare to go from 40% to 60%, then we need to say, okay, we've got something better. This cancer treatment over here, that's not the one we're going to use anymore. We're going to switch to this one that's better. We're going to leave the old and we're going to go with the new. Okay. In terms of a trial, well, the defendant would be found guilty. Okay, so that's how we make those connections. All right, so real quick here, let's go through just a couple of examples. We've already looked at this one. In the 2001 study, college students were found to study 16 and a half hours a week on average. Leading educators today believe that probability or the average has dropped. So let's say we take a random sample of 100 college students today, and we find the mean number of hours studied a week is 8 hours. So from 16 and a half in 2001 to data that we have, the average says 8 hours today. Does this seem significant? Okay, so in other words, is that different enough in your mind to say that you no longer believe that college students really study 16 and a half hours? Okay, I would say yes, that is a drastic difference. Okay, so yes, this seems to be, at least in my opinion, seems to be a pretty drastic difference. It appears that the null hypothesis of the mean being 16 and a half hours is no longer true. Now, again, we would need to do a probability to actually do that. But again, I think that gut reaction would say, like, man, we have a pretty good chance of showing that this is the case. Okay. But let's say instead, hypothetical situation, we took a sample of 100 and the average number of hours studied was 16.2 hours every week. What would you conclude? Okay, well, from 16.5 to 16.2, you're not talking about that big of a difference. You're talking about a difference of literally 18 minutes. That's probably not a huge deal. Okay, so for this sample, I would say the mean is likely to still be 16 and a half hours. Okay, because again, any sample you get, you're not going to necessarily get 16 and a half hours, but if it's still true, you think it would be something relatively close. And 16.2 seems relatively close. All right, on the next section or the next part of this section, we're going to look at, well, what happens if you do a test and you make the wrong choice? And that's what we'll be talking about next.